Hey guys, welcome back to the shop. Thanks for being here. Once again, I am excited to bring you along on a project here. A forging project in the shop, something sharp, something cool. You're probably asking yourself, what in the world is a power core Puukko or even a power core blade? That's a really good question, and I don't know the answer to that exactly. What I'm calling a power core blade is a blade in which you have a steel, typically, of course, a high carbon steel. And in the center, along the middle, you have some kind of different steel, typically, as far as I'm aware, a pattern welded steel. And that gives you a really neat accent to the blade. And that's what I'm attempting to do today. Now, I'm using a piece of our cable Damascus from the last video, if you watched that, where we made a really cool cable Damascus dagger. I have some cable Damascus left over, so I thought I would go ahead and try to forge that into a high carbon steel blade. So a couple advantages to that: the cable will not have to act as the edge, and it will simply be a part of the blade structurally and aesthetically. So I'm using 1084 high carbon steel for the main part of the blade, which is going to be the edge and the spine, and then of course the piece of cable Damascus for the center piece. Now I should point out this 1084 is not standard 1084. It's what's fondly referred to in the knife making community as Aldo's 1084, which refers to the owner of New Jersey Steel Baron Company, and it's a 1084 that has some additional alloying elements. So really good stuff, tougher than your, and a little more wear resistant, I believe, than your standard 1084, of course, depending on proper heat treating, as always. So you can see I've got those two pieces of steel sandwiching on edge the cable Damascus, and I obviously ground the edges where they're matching up to make a weld. Now, the dimensions of steel that I'm using here, if you haven't figured out already, are gonna cause us some problems. Not that they won't weld together, but it is difficult to put pressure, other than careful hammering, on a setup such as this. Now, obviously, it's not very much surface area that needs to weld, so, I guess that's good in one sense. But I'm just, I did a little packing, as it were, kind of making sure that the two pieces were together tightly. And then it's close to welding heat. But you'll see in a second here where I've got it up to a nice welding heat, and I did successfully weld it, mostly. Got some borax on there. Now at some point, you've welded your billet, and there's not any more space for the borax to get in there, but it still serves to keep the outside, or the area around the weld, protected. So it's not a terrible thing anyway. So here's where things started to go a little bit south, as you can see. There's just not a way to get consistent, straight, even pressure, on the forging press with such a narrow piece of steel. I think it was about 1/4 inch thick. So it just really didn't work that great. Of course, it was a great learning experience, and the next time I do something like this, I'll definitely use pieces of steel that are at least twice as thick, and also not as wide. I didn't need that wide of stock for the final ratio in the blade on the high carbon steel. So you can see I got some spots where the weld did not work, and that's not surprising. The tack welds that you hold your billet together with, even on your typical Damascus or pattern welded billet, it just doesn't weld right there. And now it's stretched out, so it looks like a lot longer spot that didn't weld. I could have probably paid a little closer attention to that, but anyway, we'll work with it. So here I'm cutting a V in the end, and I'm taking out the part of the spot that didn't weld. I'm taking that out, but I'm also preparing it to create the tip of our blade. And I didn't show it in the shot here, but I did grind sort of a radius on the sides of those V's, and that's also important, and I'll mention that in a minute. So just kind of grind sort of a radius and then cut off the other end that we didn't weld. So I got this close to welding heat right here. It's coated in borax right now to protect the inside of that V. And you can see I'm closing it up and brush it off, because you can't really close it up in one heat, and at least I didn't find that feasible. Put some more borax on there. So what's going to happen is we're going to weld this V together, and as we go, it's sort of the best case scenario for an open atmosphere forge weld like this, where we're going to be able to easily force out the flux and impurities as we close it up, and keeping that flux on there. So those two sides of the V that are coming together, those both have a radius on them, like I mentioned a minute ago. And that's important because that makes sure that at no point is there going to be a void in between those two pieces, which is unlikely because it's such a narrow piece of material anyway, but I think that helps also because it provides a higher PSI, because where they finally come together and touch right at the tops of those radiuses, and then they just kind of squish together and complete that forge weld as you add pressure. And so what happened is there's a little line as I completed the forge weld here, because that's a radius right there, so it didn't come together 100% on the sides, but I think it was beneficial to make sure that the center of that thickness was well forge welded. So anyway, that's a long explanation, but I think that was an important bit. And then I'm just making sure that it's squished together on the press here. Probably not necessary, but anyway, now we're squishing it out flat and gaining some width on this. And if the forge weld was going to come apart, this is one spot where it would likely do so, and no sign of that, so pretty happy with that. Now, speaking of power core blades, the only other person I've seen do a blade like this with solid pieces of steel is my buddy Austin Mueller from Mountain Man Steel. But he doesn't do it this way. He creates a plug and cuts out the exact outline of the plug, and then puts it in his blade material and forge welds it. And that also requires a lot of care and skill, because you have to make sure that you're getting pressure, 3 of 4 sides. And so in some ways could be more difficult than doing the forge weld. So you saw what I did there. I squished that tang too thin. I was going to do a full tang blade, and we had plenty of material to do that. And then I went and wasn't careful on the forging press and squished that down to way too thin. So had to chop it off and make a hidden tang. But hey, so forging out the blade here, and going for a nice sort of Scandinavian Puukko-ish style. Nice little blade here, so it's a lot of fun to forge a blade like this, and kind of think about, I don't know, the old craftsmen in Finland or wherever, different Scandinavian countries where they did for a long time make forged blades like this. So similar to this anyway. So I'm grinding off the spine right towards the tip, which is where that forge weld line is at. And you saw as I was forging the blade, forging that tip down around to where the forge weld line from that V that we closed up terminates up on the spine of the blade, near the tip, but on the spine. And that ensures that you don't have a forge weld line anywhere near your edge, because even though we've got a good forge weld, it's going to be best case scenario to keep that away from from the edge, so and the tip as well. So we're about 3/8 of an inch back from the point of the knife with that forge weld termination. And there's the blade forged out and ready for some cleaning the profile up and rough grinding the blade. Now in this project, I was planning on trying something that would bring out the pattern on the cable Damascus a little better. And the way the forged blade turned out, there's not as much of the cable in the blade as I wanted. As you saw, we had to chop off about half of our length, and so of our stock. So that was a little disappointing, but it's still there. And anyway, get this blade normalized, of course, as always, per usual. And of course do our typical grain refinement procedure and into the quench. This is another juncture at which the forge weld, if it were faulty, would likely come apart, and again, absolutely no issue, so that's always nice to see. So I'm just making sure that the blade is cool enough to not evaporate the oil when I take it out of the quench in. So making sure it's straight, turned out pretty nice and straight. And let it cool down to room temperature. And we'll get that thing tempered up. Tempered it out to 375 on this 1084, which will give us a nice edge retention. It's good for this size of blade, which is going to be used for cutting, carving, that kind of thing. All right, time to finish grind this blade, and I was always using care to make sure that we take off material where it needs to come off and not somewhere else. So get this ground down. I'm going to go to a 120 grit belt, and this is actually I believe it's a J-weight belt, which is the softer finishing belts. Not necessarily ideal. I mean, it works fine for grinding, finish grinding and stuff. This is only 120 grit, like I said, so typically you'd want to go to a higher grit. But anyway, we'll get this ground down to 120 grit. It's a small blade, so it's not like the hand sanding is going to take too long anyway. This is where you're just really making sure that your bevels are clean, straight. You know, you've got a single bevel, a single facet on each side of your knife, and of course this is a flat ground blade, so just making sure that that's clean and consistent. So now I can go ahead and finish sand the blade out, and we'll start with 240 grit paper and go all the way up to 1,000 grit. I'm going up to 1,000 grit because, of course, we're going to do an etch on the blade to try to bring out that cable Damascus as much as possible. Here I'm just refining or defining the shoulders on the blade a little better so that we have a good spot to match our bolster material up to, using the small wheel attachment. There's our blade all finished ground and ready for the etch. You can see a couple small inclusions in our cable Damascus core right there, but it's not by the edge at all, obviously, so it's not, really doesn't matter that much in this case, since our edge material is a mono steel. So there's the blade out of the etch, and it still has a bunch of oxide on it, so it actually kind of makes the pattern of the cable Damascus jump out. Once you clean it up, it softens it quite a bit. And yeah, I don't know, I haven't figured out the trick with cable Damascus yet. I guess it's hard because you're working with very similar steels within that cable Damascus. Really the only difference is slight variance in carbon content and stuff like that. So it's kind of hard, and I don't know the best way to do it yet, I guess. But etched it down 2 or 3 times, I think 3 times at least, and got a little bit of relief, as in you could feel the ridges of the cable Damascus, the differences in how it etched, but it's so minimal compared to your nickel steel, high carbon steel pattern welded stuff that it's kind of hard to work with. So here, what I was trying to do here is use some cold blue solution to actually really bring out that definition. But again, the relief on this is so minimal, unlike your typical pattern welded steel, that after cleaning up the the high layer steel or whatever, the high surface, it just kind of took it all off, for the most part. So didn't really work. But so it's going to be a subtle element to the blade, I guess. Anyway, we'll use a piece of whitetail antler for the bolster of the knife here, going for a more traditional look. Now I know that wasn't whitetail antler used in Scandinavian knives, but that's what I have, and it is a horn type material, so it'll be all right. So just squaring off the ends of the antler before we drill in for the tang of the blade. So the tang thickness ended up being about 165 thousandths, which is about 9 or 10 thousandths thicker than 5/32. So I'm actually using a drill bit that's real close to the tang thickness. But anyway, got this kind of routered out here and fitted to the tang. I'm not necessarily recommending using your drill press that way. That's what works for me. But keep working on that slot there with the carving tool and some files and whatever else we need to do. And being careful not to remove too much material. It comes off pretty easily compared to brass or steel. So keep plugging away at it here a little bit at a time. And slowly but surely, we'll get that to fit. So there it is, really close. You can see right on the shoulders where I came back and made a smaller radius, so it was something that was going to match up easier to our material. The antler that I had, it was not as wide as the total width of the blade, obviously, and so that made fitting it a little more difficult. I ended up kind of hanging the shoulders of the blade off either side a little bit, which, if I remember correctly, I've seen traditional Scandinavian knives that are similar to that construction, actually. So I think it turned out pretty nice. And then I took out some material at those junctures so that the bolster kind of fits up on the blade by about 1/16 to maybe 1/8 of an inch. So I think that looked kind of neat too. It's got a block of hardwood here. I don't actually know what it is, but got some nice figuring in it. And for once, we have a tang that isn't super long because of the size of the knife, and so I can actually use a normal drill bit to drill the whole thing out. So it's kind of a nice change. And now it's just time to square up the block of wood and the antler where it comes together. Make sure that we don't have uneven surfaces there. Obviously, it has to match up evenly. So as a last minute kind of thing, I decided to put a little blue G10 spacer in here, and for two reasons. One, looks cool, nice. I think it's a neat color to match between the wood and the antler. Secondly, by the time I squared the block down, I had lost a little bit of my depth, and I was just, barely a 30-second gap trying to get the tang to fit all the way down in there. So I just added a little more length, not a problem. So the tang obviously is hardened and tempered like the rest of the knife, and so drilling through that would be very difficult. And so you just heat that up to a dull red, let it air cool. It's best to get that heat on that tang as quickly as possible instead of slowly, because getting that up to a dull red immediately will allow you to pull the heat off much quicker, which means much less time for it to creep up to the blade. and so it actually works better to do it quickly. So I went ahead and tempered out the spine of the knife. Probably not necessary, but add a little more toughness to the overall blade, and just another little feature. Filling up the handle block with epoxy, and probably about 2/3 of the way, so there's plenty in there to bed that tang when we put it in. And epoxy on everything, in everything, and between each surface, and it just fits down in there just like that. So this is my little clamp that I use sometimes for gluing up hidden tang knives, and it works pretty good. You can use it for knives that have an attached bolster, or smaller knives like this where everything is glued on or epoxied on. So the next morning here, pull that off and everything is tight and where it needs to be. So this is sort of my preferred method if I'm going to put a handle pin in, because everything is already where it needs to be and it's secured, and so then we just put the pin in that look, with everything where it needs to be. Otherwise, trying to do it matching the pin up, when you put things back together, there's always a greater chance that it's not going to be as tight. And so it can be done that way, but this way is kind of my favorite way to do it. It's just simpler. So you see it drilling through. There's the epoxy drilling out, and then we're into the steel tang right there, and down through the wood on the other side, and no problem. So this is a 5/32 hole. Well, actually it's a hole for a 5/32 pin. That's an important distinction. So you can see the brass rod I'm using. I ground the surface of it on a heavy grit belt on the grinder just lightly to put some nice surface grooves in it. Kind of helps an additional help for the epoxy to bond and hold it in there nicely. So just making sure that there's plenty of epoxy in that hole. There's not going to be much left in it because it's all going to get squished out, but that's another reason why those surface grooves on the pin are nice. Try to allow that to do its job as well as possible. So after letting the epoxy on the pin cure, we can go ahead and shape the handle. So it's kind of just a chunk of wood right now, and I ended up unfortunately, I didn't end up with the pin placement right in the center of the handle like I wanted to on the final shaping, which should have been avoidable. A little bit of a mistake there, but oh well, try better next time. Anyway, the handle shaped up. I left it a little bit longer than I typically do, maybe a 1/4 inch longer, and man, I gotta say, this handle is super comfortable, and holding it in your hand, the whole knife, whatever else happened with this project, I have to say that the way this knife sits in your hand, the weight, where the edge indexes ergonomically when you hold it, I really like it. It's a super nice little knife for somebody to use. So whoever gets it, I'm sure will enjoy it for a long time. So get some linseed oil on that, and it's time to put an edge on this thing. Of course, I put the initial bevel on with the grinder at a low speed, carefully establishing that, and then taking it to the stone and work that in, take the burr off. And then, of course, the Arkansas stone to hone it down. And at this point, it's, when you're finished with the Arkansas stone, it's razor sharp at that point, and a really good edge. But I like to strop it, of course, especially for woodworking, and that just adds another layer or another level of sharpness and keenness to the edge, so it's a nice last step on the sharpening process. And man, the way this thing's sharpened up, just every time I do that on a nice high carbon steel blade, you know how keen and just super sharp. And I'm whittling some dry pecan wood right here, and it just cuts it. Yeah, and like I said, I can't stress enough how nicely this knife sits in your hand. I really enjoyed using it for about 5 minutes. Just to I had to go whittle something. I had to go cut something with it. So shaving sharp. So yeah, it's a nice little knife. Whatever else happened, I really like how it worked. It's going to be a great little user. So recap on the cable Damascus power core. Well, it was definitely a good forging project, and it was definitely some good practice for these techniques. I probably won't do a power core with cable Damascus again, simply because I'm not sure it's worth the trouble. It's just, if somebody has a good method for bringing that pattern out, let me know. But I do want to try this again with a nice piece of pattern welded plug, you know, something that's actually going to give us the benefit of all that extra trouble with some nice aesthetics. But neat forging project, great little knife, and overall I'm happy with how it turned out. So as always, appreciate you guys watching. We'll see you on the next video.